Bag of words and TfidF both throw away word order entirely. But word order matters. Not bad and bad are completely different in meaning, but bag of words treats them as identical. Ngrams solve this by treating sequences of words as single features. In this episode, we go line by line through what ngrams are, how to generate them, and how to use them in your pipelines. An ngram is a contiguous sequence of n-words taken from a piece of text. When n equals 1, we call it a unigram, which is just a single word and is identical to bag of words. When n equals 2, we call it a bigram, which is every pair of consecutive words. When n equals 3, we have trigrams, every group of 3 consecutive words. Each unique ngram becomes its own feature in the vector. This captures local word order and relationships that single word bag of words completely misses. To generate bigrams manually, we first split the text into tokens. Then we use Python's zip function to pair each token with the one that follows it. Passing the token list and the same list shifted by one position using slice notation creates pairs of consecutive words. The result is a list of tuples where each tuple is a bigram. This is how every bigram in the sentence is extracted. You can extend the same idea to trigrams by adding a third shifted version of the token list. Trigrams follow the same pattern but with 3 shifted versions of the token list. Each tuple now contains 3 consecutive words. The sentence "the cat sat on the mat" produces 4 trigrams. NLTK also provides a built-in ngrams function that takes the token list and the value of n as arguments. It is cleaner and more readable than writing the zip pattern manually, especially when n is larger than 3. In scikit-learn, you add ngrams to CountVectorizer using the ngram_range parameter. It takes a tuple of 2 values, the minimum and maximum n. Setting it to 1, 2 includes both unigrams and bigrams as features. The vectorizer automatically generates all bigrams from each document and adds them to the vocabulary alongside single words. The resulting feature names include both individual words and 2-word phrases like cat sat and sat on. Combining ngrams with TfidF is extremely powerful for capturing context. Here, the phrase "not bad" is treated as a single feature separate from bad alone. Without bigrams, not and bad would be 2 independent unigrams and the negation meaning is lost. With bigrams, not bad and not good become distinct features with their own TfidF scores. This is particularly important for sentiment analysis where negation words completely reverse the meaning of the word that follows them. Choosing the right ngram range is a balancing act. Unigrams alone miss context. Including bigrams adds meaningful phrases without exploding the vocabulary size. Trigrams can capture even more context, but they significantly increase the number of features and make vectors more sparse. Very high values of n produce features that almost never repeat across documents, making them statistically useless. The range of 1 to 2 is the most common starting point in practice. Evaluate it first before deciding whether to extend to trigrams. Ngrams improve on bag of words by capturing local word order, but they still have significant limitations. The vocabulary grows very quickly as n increases because the number of possible word combinations is enormous. Vectors become even sparser with higher n because most ngrams appear only once. There is still no semantic understanding, and ngrams can only capture local context within a window of n words. Long-range dependencies, like a word at the start of a sentence influencing meaning at the end, are completely missed. Word embeddings and transformer models handle all of these problems far more effectively. You now understand ngrams, how to generate bigrams and trigrams manually, how to use them with CountVectorizer and TfidfVectorizer, and how to choose the right ngram range for your task. In the next episode, we use everything we have learned so far to build our first real text classifier using Naive Bayes. If this helped you, subscribe so you do not miss the rest of the series.